when we talk about a weak acid, when you talk about a weak acid, when you talk about a strong acid, right? How can we experimentally determine? As per the past paper we just saw now, that a weak acid and a strong acid will be has to be determined experimental. The main fundamental is that a weak acid will be in equilibrium, isn't it?
Yeah.
Equilibrium. And always remember that the equilibrium will be lying towards the right. The equilibrium means hardly any weak acid will be getting dissociated. This point is clear. So if you take a weak acid will be having a very less dissociation, and thus it will be in equilibrium. So the ions will be very
Yeah.
less. On the other hand, if you take a strong acid, Hb, a strong acid will be fully dissociated. This point we have to know this very importantly, right? It will be 100% dissociated, right? It will be completely dissociated. And it will be what? It will be having 100. If you take 100 Hbs, 100 H plus will be there, 100 B minus will be there. If you take a weak acid, out of 100, it will be around less than 1% in also, right? Less than 1%. See, if you take ethanoic acid, it is 1.8 into 10 to the power minus 5. This is the Ka value. This is the Kc value, right? Dissociation value, right? See, 10 to the power minus 5. So if you take 1% also, it will be 1 and 1. So you have to harp in this important part. The weak acid has got very few ions in the solution, in the ionic state, the dissociated state. Did you get my point? Whereas in a strong acid, it has got a huge amount of ions which are roaming around in the solution. So this is the basis of our experimental difference we have to pick up. If you see that when we take a conductivity meter depends upon what? Guide me. Amount of, tell me, free ions or free electrons. Is it clear? Did you get my point, right? Conductivity depends upon what? It depends upon the free ions or the free electrons. This is very important, right? Now, moving to this part, we have to know that if we have got more free ions, the conductivity will be less or more? Please tell me. If you have got more free ions, conductivity will be more, right? So a
Yeah.
strong acid has got 100 B minus and 100 H plus because it has got 100% dissociated. So conductivity will be more here. Also,
Yeah.
if we take a weak acid, if you take a weak acid and a strong acid, right? And we take a bulb, electrical circuit with a bulb. Can you tell me that where will the bulb glow brightly? Similar concept. The conductivity depends upon free ions or free electrons. In a weak acid, it's got very less amount of free ions roaming around. But whenever we are taking a strong acid has got huge amount of ions roaming around. So thus, if you see, when we talk about conductivity, the weak acid will be having very less conductivity and the conductance will be less. Number two, we can
Yeah.
also put a electrical bulb, electrical circuit with a battery. Now the weak acid, the bulb will be glowing less brightly, right? And in a strong
Yeah.
acid, the bulb will be glowing more brightly. Now, this is also important about the rates of the reaction. We learned that whenever we are taking an acid plus a carbonate, so acid plus carbonate gives you what? Salt plus water plus carbon dioxide. If we take a weak acid, the carbon dioxide emission will be much less. Can you see this? Understood the part, right? So the carbon dioxide emission, when we put a acid plus carbon gives you salt, water, and carbon dioxide, the carbon dioxide emission will be very less. But on the other hand, if you take an acid plus carbonate and take a strong acid, see, the carbon dioxide emission will be gushing. See, huge amount of, because all acid will be dissociated in a weak acid, sorry, strong acid. Similarly, if you take acid plus metal gives you what? Salt plus water plus H2. Sorry, salt plus hydrogen, right? So, my
Yeah.
bad. So acid plus metal
No,
gives you salt
it
and
is
hydrogen.
H2. It is H2.
H2, right?
Yeah.
Salt and
Yeah.
hydrogen, right? So similarly, weak acid will be having very less amount of hydrogen gas coming out slowly. Whereas in a strong acid fully dissociates here, fully dissociates, right? Thus, it will be having huge amount of the HCl gas, sorry, the huge amount of H plus H2 gas coming out. Now, this was the rate of the
Yeah.
reaction. Now, going to this part, we also know this trick that if you take a weak acid and a strong acid will be having a pH of 0 to 1 because it has got huge amount of H plus ions, right? We know that the pH will decrease if the H plus ion increases. Typically, a weak acid has got a pH of 2 to 6. So we tell that we can also put a pH meter. When a pH meter you're putting, the strong acid will be having a pH, a very low pH, and a weak acid will be having a pH above 2 to 6. Means because it has got a less amount of H plus ions. So this is the concept we have to tell, right? Now going to this thing. In this In this past paper question, we have seen what? Write an equation to show this behavior or that HCN is a weak acid. Always we have to learn that weak acid has to be always denoted by a double-headed arrow, because it will be an equilibrium and hardly dissociates, hardly. So HCN, you will be giving you can write H plus Cn minus, you can write AQ over here, we can add water also, right? We can add water also, that is also also the thing. But yes, we have to write a equilibrium sign, because it is and a strong acid, if you say that that HCl is a strong acid, show its behavior, we have to put a we have to put a single headed arrow, right? H plus Cl minus, right? So this is very important that we have to do. Now see, outline the two ways by which we can determine that a solution was 0.1 mole per decimeter cube HCl rather than this, right? So this is the distinction between a weak acid and a strong acid. So I told you four different ways, right? We can do it via conductivity meter, right? So it will be a high conductivity, it will be a low conductivity. We can use a pH meter. HCl is a strong acid, the pH will be around 0 to 1. You can tell like this, low pH. And for the HCl, it is a weak acid, it will be having what? It will be having a higher pH, right? It will be having a higher pH. Third, rates of the reaction. If we put HCl and calcium carbonate, right, in the test tube, if we put HCl and calcium carbonate, what we see in the calcium carbonate, what we see that the carbon dioxide gas will be gushing out fast. HCl, the carbon dioxide gas will be gushing out very slowly. This is the difference you have to tell. Understood this part, right? See, determine the pH of zero point 0.1 mole per decimeter cube. This determine the pH of 0.1 mole per if the H plus ion concentration is this. They've already told you. So this is negative log of this. So write an expression for KC. Wonderfully done. So this is the question you'll be getting. Thank you.